Rahim. This is a question, October 1743 variant, and question we have given here. Let me start explain. So a particle start from, wait a minute, particle starts from, hold on. Yeah, yes, question here. Yeah, a particle start from, is very clearly mentioned here. Particle start from origin, and that particular time is velocity given by him 0.4, and s is 0. Reason, because starting from origin. Okay, further he given us this acceleration formula. A is equal to k times 2. Compare your working with my working. Look, I'm going to do. Okay, and he mentioned one extra part. T0 equal is given data number 1 and data number 2. When time is 1, velocity is 0. So we have two connections. Time 1, velocity is 0.1. So we have two links. Why two links? We come to know. And he said, show that k value is 0.1. So all of you know the three levels are there: displacement level, velocity level, acceleration level. If I differentiate, I will get up. Differentiate. Again, differentiate, I will get up. But if I come down, integrate, you know it very well, integrate. Again here, integrate, okay? So I am on the level of acceleration. I'm looking for velocity. So I will integrate. So let's start. I'm integrating now. And when I integrate, I get velocity equal to integral sign k. You copy here or copy outside, no problem. Why? Because k multiplying with a whole bracket. Whole bracket can bring outside. But let's say k multiply with one factor, I cannot bring outside because it's multiplying the whole factor. You can k bring outside. If you keep inside, no issue at all. Alhamdulillah Rabbil Alameen. So what is the rule of integration? You know it very well. Increase the power by 1 and divided by same. Increase the power by 1 and divide by same. And this become 2t and plus c. Plus c I'm writing outside. We can't write in the bracket because k is multiplying. Okay, now this is cancel out. So v equal to k in the bracket t cube minus 6 t square and plus 2t and plus c. Now I'll use this data one by one. T0 V4, I'm writing here, T0 V0.4. So when I plug in every T0, what happens? Let's see. 0.4 coming here. 0.4 equal to k time to 0 minus 0 plus 0 and plus c. Finally, I got c value 0.4. If you're not getting 0.4, it means some mistake is there, right? So let's plug in back an equation. Please plug in back. Okay, some student trying to solve it without plugging back. And you have to plug in back, and this way question become easy. Now, I did not utilize second link, okay? When I use second link, let's start. What is the link number 2? T1 and velocity is 0.1. So use it. So velocity coming here 0.1. K as it is, this one come and every time at t value. And I believe it's nothing hard. And finally, I get what? 0.1. This is 3, and I got a negative 3k is it plus 0.4. 3k comes this side, this go on other side, and 3k is equals to 0.3, and 3 divides. Alhamdulillah Rabbil Alameen, proved. So my k answer, what he was asking us, proved. See, he was asking us. So part number next, he's saying find expression for displacement. Again, come back on the planning. If you have acceleration, you have to integrate to get velocity. Again, integration to get a displacement. So let's see and pick this connection. So I will plug in this 0.1 here, and I use this whole connection once again. This link, I will copy paste here. So when I copy paste here, you will see inshallah. Okay, k value is 0.1. I have it here. And c value I got 0.4. It is already, we know it. Okay, now we know this connection v t0 s0. This connection will help us to get a value. So here I'm writing on the top, t0 s0 is confirmed. I will integrate. When I integrate both sides, students, what will happen? So here I got s been displacement, or here I'm writing 0.1 t to the power 3, and this one, okay, this is clear, and plus 0.4, and dt must be there. Now if I integrate, what happens? This untouched, increase the power by 1 and divide by same, and increase the power by 1 divide by same, increase the power by 1 divide by same, and 0.4 turn 0.4 t, and plus c1, because c I used already here. C used already here. I take another variable. Now I will plug in this data. Which data? This right on the top. You have T0, S0. Okay. When I plug in 0 here, it gone. 0, 0, 0. This also gone. And 0 here, gone. So C1 turns to be 0. So I have to plug in this value and show back here. So displacement expression purely, I got it, which I'm going to write for you. T4 by 4 and 2t cube plus t square plus 0.4t. Alhamdulillah, here Rabbil Alameen, I think point is clear. And he was asking for an expression for displacement. But now last part, he said, prove it will come to origin back. You know, students, what is the point? This is observer. When it goes away and come back, same position, for example, go and come back same. So displacement 100% zero. Actually, we have a three concept with displacement, I tell you. For example, this is observer's position. For example, if particle standing, a particle is beside observer, displacement zero. If particle is ahead of observer, displacement is positive. If particle is behind of observer, displacement is negative. So three criteria we have: displacement positive, displacement negative, and zero. So whenever he say particle back to observer, so it means 100% displacement zero. This is a key point here. So I will plug in these two back here, 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 here. If I get a zero, it will prove. So let's try to solve. 2 to the power 4 over 4, 2 times 2 to the power 3, and 2 to the power 2, and let's try to solve it. So here 0.1 in the bracket, 16 by 4, I got a 4. This is a 8 to the 16 and 4. So n plus 0.8 come here. And now I have a type in calculator. Please, this is a, I got negative 8 into that, negative 0.8 and positive 0.8. So alhamdulillah, Rabbil Alameen, displacement 0. It means prove that particle is back to the starting position. And I hope so point is very